All right, in this video, we're going to be going over an application for exponential functions, and that is Newton's law of cooling. This law states that for a cooling substance with initial temperature of TO, the temperature T after T minutes, where T sub S is the surrounding temperature and R is the cooling rate of the substance. So we have all of these variables, and they all go into the equation for Newton's law of cooling, and that equation is capital T of baby T equals T sub S plus parentheses T sub 0 minus T sub S times e to the negative RT. And so all these pieces, we have big T, which is the temperature after T minutes. So this is the final temp, is big T. Little t is the amount of time in minutes. T sub S is the surrounding temperature of whatever it is that whatever surrounding your thing that's cooling. R is the cooling rate of said thing that is cooling. And T sub 0 is the initial temp. That's the temp it starts with. So we're going to get started with example 1. You are cooking alicha, an Ethiopian stew. When you take it off the stove, its temperature is 212 degrees Fahrenheit. All right, 212 degrees here. This is the initial temp, T0. The room temperature is 70 degrees. Okay, 70 degrees, the room temp. That is the surrounding temp, TS. And the cooling rate of the stew is R equals 0.046. So let's start by plugging these three numbers into the equation. So we've got T of little t equals TS is the surrounding temp, so that's 70, plus T0 is the initial temp, 212, minus TS, which we said is 70, times e to the power of negative R, so negative 0.046 times T. So there's our equation for this first example, and we're going to use that to answer questions 1, 2, and 3. So question 1 says, how long will it take to cool the stew to a serving temp of 100 degrees? This right here is what we want the final temp to be, and that's going to be T. And we're looking for how long it will take. That means baby T is what we're solving for here. So we're going to plug 100 in for T. So we have 100 equals 70 plus 212 minus 70 times e to the negative 0.046 t. And now we're going to solve this equation. So I'm going to start by just simplifying. 212 minus 70 is 142. Bring everything else down. And now I want to solve this for t. So I'm going to start by subtracting 70 from both sides. And I get 30 equals 142 times e to the power of negative 0.046 t. I'm going to take this over here to get some more room. And now we're going to keep solving for t. The next step I'm going to do is divide both sides by 142 to cancel this out. 30 divided by 142 is a decimal. I would rather keep it in fraction form, so that would reduce to 15 over 71 in my calculator, equals e to the negative 0.046t And now we've got t, which is stuck in the exponent of an exponential. And so the way that we're going to solve this now is to switch to logarithmic form. So we've got log base e of 15 over 71. Remember, log base e is just ln. So 15 over 71 equals the exponent, which was negative 0.046t. Finally, to solve for t, we're going to divide both sides by negative 0.046. And we get that t equals, and then using our calculators, I get 33.796. And that is really minutes. So let me erase t here so I can add those units. And there's our answer. All right. In this next question, how long will it take to cool the stew to 100 degrees when the room temp is 75? So now in this problem, we are changing the surrounding temperature. This is updating TS to be 75 when it was 70. We're still heating or cooling to a temperature of 100, so that's T. So get 100 equals now 75 plus 212 minus 75 times e to the negative 0.046 t. And we are going to solve this for t. So 212 minus 75 is 137. So again, 100 equals 75 plus 137 e to the negative 0.046 t. Next, I'm going to subtract 75 from both sides, and I get 25 equals 137 e to the negative 0.046 t. Next, I would divide by 137. 25 divided by 137, I think is not very pretty. It stays as just 25 over 137. That fraction will not reduce. Equals e to the negative 0.046 t. And now we've got t stuck in the exponent, so we need to switch to exponential form. So that's going to be log base e, which is ln, of 25 over 137 equals negative 0.046 t. All right, from here to solve, we're going to divide both sides by negative 0.046. And plugging this into my calculator, we've got ln of 25 divided by 137 divided by negative 0.046 equals 36.98 minutes. That is t. All right, let's try one more. How much sooner can your guests begin to eat when the serving temp is 140 instead of 100? So 140, that's going to become our new t, and we're going to plug that into the formula. So let's also assume that the room temp is back to 70 degrees, the original from the problem. So we've got now 140 equals 70 plus 212 minus 70 times e to the negative 0.046 t. And we're going to solve this. Starting 212 minus 70 is 142. So we've got 140 equals 70 plus 142 times e to the negative 0.046 t. The next thing I'll do is subtract the 70 over I get 70 equals 142 e to the negative 0.046 t. Then I'll divide by 142 on both sides. And that fraction reduces to 35 over 71 equals e to the negative 0.046 t. And now we've got t stuck in the exponent, so we need to switch to log form. So log base e of 35 over 71, but we know that's ln, equals negative 0.046 t. Last step to solve for t would be to divide both sides by negative 0.046. Plugging this into my calculator, and I get 15.377 minutes equals t. Now, the question was, how much sooner can our guest begin to eat? Well, originally it was going to take 33.796 minutes, and now it's only taking 15.377 minutes. So if I were to subtract 33.796 from problem number 1, minus the 15.377 that we just found, I get 18.419 minutes. So they can eat 18.419 minutes sooner. All right, try example 2 and example 3 on this page, and then check the answer key to check your work.